Artificial intelligence surrounds us in day-to-day applications. Though still intimidating for some, artificial intelligence, or AI, has been there for decades. AI is also an asset for many scientists, as different types of data-driven methods powered by AI gain importance. Machine learning, pattern recognition, statistics, data mining, etc. have huge potential for new lines of multidisciplinary research. Air pollution is both unpleasant and harmful. Even in Finland, over 1,600 premature deaths annually are related to air pollution. So far, air pollution has mainly been predicted by complex atmospheric models, which do not take the human factor into account. In real life, human behaviour is crucial to that equation. Despite the role of infrastructure, daily choices of individuals ultimately generate traffic, and these choices are hard to predict.
These behaviors of people and society, they constantly change in response to many different things in the surroundings. It can be legislation, it can be small things like weather, it can be considerations of time and money, or big global events like a pandemic or forest fires or hurricanes.
The ATMOS research group at the University of Oulu is funded by the Academy of Finland. It uses agent-based simulation to represent individual people in the atmospheric model.
In this work, we are also collaborating with social scientists to develop these agent-based simulations of how individual people respond to changes in their environment. But the key part is that this is only made possible by these advanced AI methods, that we can place a model for individual people and their interactions with the environment and how that affects their behavior into an atmospheric model.
The Helsinki capital area suffers from congestion, noise, greenhouse gas emissions and air pollution. Yet empirical studies show that awareness does not convince people to shift to more sustainable travel modes. Decision makers would largely benefit if they knew in advance which decisions implement greener habits.
Ultimately, what we hope to get out of this basic research is a prototype for a simulation tool that allows, for example, different stakeholders such as decision makers, but also companies or individual citizens to estimate the total outcome of different changes that they implement.
Science is vast, and so is the concept of AI. Though based on mathematical thinking, AI also has a lot to offer to social sciences through multidisciplinary approaches. For example, gathering of information. Very often, search engines give irrelevant or uninteresting results, or they can be out of context. The computer cannot comprehend what particular documents on the web are about. To provide more intelligent access for information, scientists have created the Semantic Web, where contents on the web are made comprehensible to the computer.
Another major benefit of the semantic web is that it can aggregate data from different data sources, even across language barriers. So we can get more data into the systems and in an interoperable way, so that people can be served with not only more intelligently the data, but also more data.
A worldwide pioneering semantic web concept has been developed in cooperation with the University of Helsinki and the Aalto University. It is a series of 12 semantic portals, each dedicated to a certain context. For example, the biography sample is a collection of over 13,000 biographies held by the Finnish Literature Society. These were transformed into a linked data service and enriched by linking it to the data of 16 external sources, such as Wikipedia, libraries, museums, and other archive collections. If you click on a particular biographical subject, you get a lot of interlinked, rich content about them. You can compare their lifeline on an interactive map, or you can select different life events from a list composed from different biography sources.
We have integrated the search and exploration systems with data analytic tools. So you not only get the possibility of search and explore the data, but also do data analysis and find interesting patterns of knowledge in the data.
For example, you can compare the places of birth and death of generals and clergymen in Finland in the 19th century and find out that generals moved a lot more than the clergy, who tended to remain in one place.
We're using artificial intelligence for solving problems. So not only do we provide the user with the tools for solving the problems, but we can provide him with artificial intelligence that can solve the problems by itself.
Spectral imaging is a technique that can help determine many aspects of a certain object just by looking at it. The human eye can see light from the visible band of the light spectrum. Many more bands of non-visible light exist for the hyperspectral camera to see. The Spectral Imaging Laboratory at the University of Jyväskylä is a leader in this field. For example, combined with AI and mathematical modelling, hyperspectral imaging can be used to determine whether a painting is genuine or a forgery. This painting is supposed to be a genuine work by the painter Frans Hals, a Dutch Golden Age painter. Hyperspectral imaging, however, detects it has been painted on a 17th century floral painting. Finally, chronological analysis of the pigment reveals it had been painted in the 1930s. Hyperspectral imaging has huge potential. In a project financed by the Academy of Finland, researchers at the University of Jyväskylä teach AI to recognize skin cancer from certain patterns in hyperspectral images. It could be used for early detection of skin cancer.
Actually, this early detection is crucial in skin cancer because when cancer is detected early, the costs of this treatment is very low and probability to survive is very high.
This invention could revolutionize skin cancer detection globally. It is a brilliant example of how science based on AI can result in commercial applications, like self-diagnosing tools on cell phones.
The first sensors were the size of this kind of device here, but our future is more like devices something like this. So it means that sensor can be actually in a smartphone, so you can actually screen your moles and see if they are cancer or not.
The Academy of Finland actively promotes cutting-edge science through the application of AI. The ability of science to continually evolve, progress and make breakthroughs is an essential social benefit.
The funding from Academy of Finland IPSA program has been absolutely crucial for us to do this research. It has allowed us who are atmospheric scientists to learn how to use these advanced AI methods to develop our own research.